Hello and welcome. In this video I will cover the creation of a few elements of the shot that you are watching right now on the screen. I can't cover everything, the video will be too long. So that said, let's dive in. So let's start reading datetime information from the system. Let's create a font to visualize the data. Maybe we can switch to a dark background for readability. Okay. And create a Python node. Now, these two lines are just saying, give me the current node, which is this one. Let me call it date info. Okay. Let me import the datetime module. This is Python, has nothing to do with Houdini specific. Import datetime is Python. And we can create a date using datetime.datetime. If you want the current datetime, you can use now, or you can specify year, month, day, hour, minute, and seconds. And you have a date. If you print the date on the console, you have what we have set here. So now we can create a detail attribute on this node, and the syntax is geo add attrib the attribute type, which means point, vertex, primitive, or detail. In our case, we want a detail attribute. Attrib type global is the name in Python for the detail attribute. The name of the attribute, let's set it to myDate, and the default value is an empty string. Now we can set a value on that. Set global attrib value. The name of the parameter of the attribute is myDate, and the value is myDate. We are formatting a date, str ftime, and we can format as we want. For the detail, you can look online. In my case, I will say B uppercase D, comma Y, and now we should have a detail attribute here called myDate, and this is the value, September 23rd, 2024, which is what we set here. We can also set a time value, my time, using a different string for the formatting, like hour, minute, I guess, and seconds. You see, my time. And we can, let's say we want the current day of the week. My day, let's call, okay, and the syntax is a capital A, if I remember correctly. My day, Monday, okay, which correspond to this date. So now in the font we can use these informations. Instead of a text, we can use a backticks to evaluate the expression. Detail S, because we are reading a string. the name of the geo and the property. Name of the geo is date info, and here we have let's start with my day. Okay, on another line we can use my date, and here my time, and we have a calendar. Okay, now how can we animate this stuff? Let's say we want to add a day every I don't know, 10 frames. Before creating the attributes, I can say frame is equal to how.frame. This is the number of frame corresponding to our timeline. And as you can see, as soon as we click outside, we have a new icon, green icon here, which means that now the node is time dependent. And for the value, let's say value is equal to frame. I need another module here. Import math, the math module, because I need the floor function. Frame divided by 10, and my date plus equal datetime dot what's the name, time delta, I guess. The first parameter is day, so we can add value here. So now every 10 frames we are adding 1 day to my date. So let's start the animation. You see? And so on. Okay. We can do the same with the time. So instead of adding a day every 10 frames, let me add a second every second. Instead of using this, the first parameter is day, so 0. The second parameter is second, and we can add the current time. Our time is the time corresponding to our timeline. So now we should have a working clock. Okay, so we can, if we start from, let me set this one to 31, 53, 59, 55. Happy New Year. So, and this is how you can read datetime information from the system. Okay, now let me show you how to create this element here. We have a circle with 60 divisions, because we have 60 minutes, and every 15 minutes we have the long one. Every 5 minutes we have the middle one, and every minute we have the short one. So let's start with a geometry and create a circle on the ZX plane with 60 divisions. We want an open arc, so we have 61 points right now, and we can fuse them, so we have 60 points. Okay. And right now the 0 is here. I want the 0 here at the top, so we can rotate the circle by 90 degrees in this direction. So the 0 is here now. And create a angle. So let's define the parameters. The short length, the mid length, and the long length. Okay, so now if ptnum modulo 15 is equal to 0, let's start with the long one. So we want to create a point here, a new point, and create a segment. So the position of the new point will be vector pt position is equal to the current position times the long length. Basically, we are using this parameter here, long length, as a percentage. Int pt is equal to add point pt pos. You see now we have all the points in the center because we have long length 0, but at 1 it will be equal to the initial position. And now we just need to create the segment. Add prim 0 polyline from ptnum to the new pt. And now we have the segment. Okay, the same for the 5 minutes. So else we can just copy and paste all this stuff. If ptnum modulo 5, we can use the mid length. And modulo 1, basically, we can use the short length. Okay. And we have our divisions. Now there is a problem. If we zoom in, you see I would like to have more resolution over the circle. So if we increase the division here, let's say 120, we have a problem. So we can define, let me go back to 60. Let's define a controller. Maybe we can change the color and the shape. And let's create a spare parameter visible integer. Let's call it resolution. So resolution 1 will be 60 division as we have now. Resolution 2, and we can now take this parameter, copy, paste relative reference, time 60, and now we have double the points. And in the script, we can use the resolution attribute. Int resolution is equal to chi resolution, paste. Now we have 2 here, and instead of say ptnum modulo 15, we have to type 15 times resolution. Everywhere. Okay. Now we have our topology, but we have doubled the number of points here, so we can increase the resolution without changing the topology. Okay, so maybe this one is too long. Okay, now this is the outer circle. For the inner one, we can just copy and paste. Let's create a merge node. Now just reduce the radius here. And instead of having a length less than 1, we can go above 1. And we have our shape. Okay. Another element is this ring here with flashing squares. So let's see how to do that. So, new geometry. Create a circle on the ZX plane. Maybe reduce the radius a little bit. Okay, and for the divisions, let's say 240. Open arc and fuse. Okay. Now we can use to create the ring. We can use a polyexpand 2D and expand only outside and offset the surface. Now we have the ring, and we can play with the divisions until we are satisfied with the result. So, okay. Now it's really important to shuffle the primitive numbers. Right now, as you can see here, the primitive numbers are in order. I prefer to have something like a random sort, so primitive sort random, and I will explain why later on. Now we can split the primitives, so we have unique points for each primitive, and now we can animate. So inside a solver, let's create a wrangle running over primitives. Now we are going to create a couple of attributes, an integer one, I at active, and a float value. Basically the mechanism is we can activate randomly some square. After that, the value will start to decrease from 1 to 0. So let me create a float amount and a float random, which is a random based on the prim num, plus something depending on the frame. Let's say every 5 frames, for example, floor at frame divided by 5. If the random is less the amount, I at active is equal to 1 and f at value is equal to 1. If f at value is greater than active, let's start decreasing the value. So f at value is equal to f at value minus something, 0.05, and maybe we can clamp the value between 0 and 1. Value here, let me see, value is not really visible here. Let me go back and first of all let's transfer the attribute, let's promote the attribute to points, from primitive to points, value, and now use a color just to show you what's going on. Ramp from attribute, value, they are not decreasing smoothly. Let me see what's going on here. Because this one is wrong. Okay, maybe they are too much now, so we can decrease the amount. Even more. And we have our result. Now let me show you what happens if we don't shuffle the primitive number. This is the sort, deactivate it. We have a complete different result. Okay. Okay, now let me show you how to create these background circles spinning around. So let's create a new geometry, another circle on the ZX plane, division, whatever you want, because we are using the circle just as a reference. Create a point here, maybe the circle open arc, create a point in at the origin, and we can replicate the point using as a shape a circle on the same plane, and the sides enough to cover the entire disk, something like this. Okay, so let's start creating a ID attribute. We will use it later. I at ID is equal to ptnum, and let's animate the points. So let's start creating a speed variable. And our time float will be time times speed. Now the basic equation for the circle is set cosine of t, the y coordinate is 0 because we are on the zx plane, and sine of t, and the radius for each particle is equal to the length of p, because this is basically the distance from the origin, and we can multiply the vector for radius. So with speed 1 we have something like a radar. Okay, let me create a trail node with 100 length and maybe 0.5. Okay, now we have an ID attribute that we can use to create the polylines. Polygons by group by attribute ID. And we have the lines. Okay, now we have to shuffle a little bit the speed and the phase, the initial phase. So let me create another, let's call it phase, a random value based on the ptnum, which is between 0 and 1, so we can fit 0, 1 between, I don't know, 0.2 and 3. Multiply the time and add the phase to the cosine and the sine. And now we have something more interesting. We can decrease the speed. Okay, so thanks for watching.